Okay, the following is a video about 5.5, and that is substitution, indefinite integrals and the substitution rule. So substitution is basically the opposite of the chain rule. You've kind of got this weird notation here, but this is the same notation that you would get after doing the chain rule by taking the derivative. So I wrote that here. This is the derivative after using the chain rule. So we're kind of doing the opposite of the chain rule. Okay, now what we're going to do is something called u substitution. Now what I want to do is integrate this function, 4x cubed over the quantity x to the fourth plus 1 quantity squared. Now, I don't have a rule for this, okay, but here's what I notice. I notice this, that if I take this function in here, x to the fourth plus 1, okay, if I look at that function, what I notice is that I see a form of its derivative in my numerator. Okay, and that's kind of interesting. So when we did the chain rule, we would take the derivative of our outside function and then multiply by the derivative of our inside function. Okay, so what we want to do is we actually have a value for u. U is equal to x to the fourth plus 1. And what I want to do here is I want to rewrite my integral as 4x cubed over u squared dx, okay? Now, here's the thing. I've done a little bit of substitution here, but what I notice is that I have this, the rest of this, this integrand, 4x cubed, and it's being multiplied by the differential x, okay? Now, what I want to do is do some more substitutions. So what I have is I have that u is equal to x to the fourth plus 1. Now, if I took the derivative with respect to x of this inside function here, d dx, well, I would get that du dx, okay, this is the same thing as me saying u prime, okay, is equal to 4x cubed, okay? Now, here's an interesting thing, and it's something that we really haven't talked a whole lot about lately, but that is the fact that I can actually take this derivative and express this in terms of my differential of u, and I can multiply both sides by dx. And what I end up getting here is that the dx is divide out. I get that the differential u is equal to 4x cubed dx, okay? Now, what I have here is that I have this 4x cubed dx right here, okay? And what I can do is I can now replace that with the value du. So I have the integral of 1 over u squared du. Now, here's the thing. All I'm trying to do is calculate the antiderivative of this, okay? And so this is, it kind of looks like something I can take the antiderivative of. Let me continue to rewrite it so we can take the antiderivative. So if I integrate u to the negative 2 du, then this is something that I can integrate, okay? But I have to have everything in terms of u before I can actually integrate this. So I end up getting this. I end up getting, what do we, increase this by 1, so we get u to the negative 1, and then we divide by our new exponent, and then we add the plus c. So I really end up getting this. I get negative 1 over u after I simplify this plus c. Okay, and what I want to do is I want to put my u back in, and so I can resubstitute for u, and I get negative 1 over the quantity x to the fourth plus 1, and that's all plus c. Okay, and this is my antiderivative. All right, so how could we tell if we how can we tell if this is the correct antiderivative? Well, what we can do is we can actually just take the derivative. So I could do d dx of negative 1 over x to the fourth plus 1. And I would need to use the quotient rule, and I would take my low function, which is x to the fourth plus 1, times the derivative of the high, which would be 0, minus the high, which is negative 1, times the derivative of the low, which is going to be 4x cubed. And this is all over the bottom squared. So I get x to the fourth plus 1 quantity squared. This goes away. This becomes positive. So I end up getting 4x cubed over the quantity x to the fourth plus 1 squared. okay, and that is my integrand. So we did do this correctly, and this is the process, guys, that I go through every time, okay? In the first couple, we'll actually choose the u value, but then it'll be up to you to actually choose that value for u. Okay, let's take a look at the next one, which is number 8. And what we've got here is we want to use this value for u of 2x squared, which is actually the angle measure right here. So what I would do is I would rewrite this, and I would say, okay, I have x times sine of u dx. Okay, now the reality here, guys, is that I really don't have a rule for this. But I notice that if I have this function 2x squared and I have this other function x and dx, I kind of notice that x is a form of a derivative of my inside function here for u. So what I can do here is I can write it like this. I can say that u is equal to 2x squared, and I can then want to take the derivative of this, and I get that du dx is equal to 4x dx. Okay, no, hold on, not 4x dx, just 4x. Okay, then what I want to do is multiply both sides by the differential x, and so this divides out and this divides out, and so I get that du is equal to 4x dx. Now that's pretty close to what I have here. What I need to get is an x dx. My whole objective is to get rid of this and substitute for that. I'm pretty close here. But what I would have to do is I would have to divide both sides over here by 4 in order for me to get 1/4 du is equal to x dx. Now that I have x dx, I can substitute 1/4 du back in up here. And so now I get the integral, let me rewrite this, as the integral of 1/4 sine of u du. And this is something I can take the antiderivative of. I can take out the 1/4 and multiply it up front. I could do this a number of ways, but I get sine of u du. Now you have to ask yourself the question, the derivative of what gives me sine of u? So I end up getting this. I should have equal signs next to all of these, sorry. But I end up getting this. I get 1/4. Remember, we have a constant multiplier, so it just stays as 1/4. The derivative of what gives me sine of u? And that would be negative cosine of u plus c. The derivative of cosine gives me negative sine, so negative cosine will give me positive sine. So let's kind of simplify this, plug our u back in. We get negative 1/4 cosine of u, which is what, 2x squared? And then plus c, and that's our antiderivative. Okay. Okay, I'm going to do one more. Hopefully this will help you guys out. Let's go ahead and do this one. Now, they're giving you the values for u. All right. So here I want to rewrite my integral as, I'm going to rewrite this whole thing first. I don't like it when they put the dx up here. I like when they have it as 1 over the square root of 5x plus 8 dx on the side. Okay, this and this are the same thing, doesn't really matter. Okay, but what I'm going to do is I'm going to plug in my value for u, and I'm going to get the integral of 1 over the square root of u dx. Okay, all I've done is just substitute for u. Okay, but I need to get rid of this dx. All right, and we'll be able to, but this one is a little bit tricky. What I've got here is I've got du dx is equal to 5. Okay, I'm going to multiply both sides by dx and by dx. So then I get that du is equal to 5 dx. And then if I divide both sides by 5 here, I end up getting that 1/5 du is equal to dx. And my whole objective was to just get dx by itself and get it equal to something in terms of u. Okay, so what I'm going to do here is I'm going to substitute this in, and I'm going to get the integral of 1/5 times 1 over the square root of u du. Okay, and all I did was plug this in for dx. Okay, and because I'm multiplying, I can rearrange the order in which I multiply. It doesn't really matter. I'm going to pull the 1/5 out front, and I'm going to multiply that by the integral of 1 over the square root of u du. Okay, And then I'm going to rewrite this because still I can't take the antiderivative of this form. But I'm going to pull the 1/5 out, and I'm going to rewrite this as u to the negative 1/2 power du. Okay? And then from here, I can take the antiderivative. All right? But it's in terms of u. And so then I get 1/5 u to the positive 1/2, and I'm going to divide by 1/2 plus c. Okay, let me simplify this. Dividing by 1/2 is the same thing as multiplying by 2, so I get 2 over 1 times 1 over 5 times u to the 1/2 power plus c. So that gives me 2/5 u to the 1/2 plus c. And then u was what? 5x plus 8? Let me just check. 5x plus 8. So let me plug that in, and so our antiderivative is 2/5 times the quantity 5x plus 8, all raised to the 1/2 power plus c. You could also write this as 2/5 times the square root. So 2/5 times the square root of 5x plus 8 plus c. Okay, so either of these would work. And these are the basics of doing integration by substitution. There's going to be a lot of videos posted about this, so please check Edmodo for more videos. Thank you.